Mr. Jackson, I got it already. Stop talking. Stop repeating yourself. Just move on already. It's going to get crazier, so I got to make sure you're okay with at this level, okay? So when we get with 3 sets, you know what I'm talking about. Okay. Make sure you pay attention to this. So yesterday I briefly talked about the 3 different, there's 1, 2, 3, 4 sections. Sean, pay attention for now, okay? There are 4 sections. There's this, and the outliers that make up your universal, okay? You got to be able to figure out what is only A, what's the intersection, what's only B, and you got to be able to figure out the outliers. You need, guys, you need at least 3 out of the 4 to solve things that are missing. You need 3 out of the 4 to solve for things that are missing. That's where we're going now. So let's go to these formulas. I would definitely say this is study sheet material. This is Venn diagrams, 2 Venn diagrams. If you're going to add this to your study sheet, make sure you tell yourself that these formulas are when there's 2 Venn diagrams. And the notes on the side are very important. Remember that the union does not include outliers ever. Okay? It refers to the elements that exist in at least one of the sets. Okay? So let's see if you can follow. I'm going to try to zoom out so that we can have our diagram up there with the formulas at the same time. That just works. Okay? So the number of elements that are in the union of the 2 sets present can be found by taking your universal and subtracting the outliers, right? So these are the outliers that you would be taking away. So this is always true. This is always true. Okay? At the same time, so this is what you would do if you have the universal and you have the outliers. To subtract, you get the union of the sets. At the same time, this is also true. The union of the 2 sets is taking A only, B only, and the intersection. So I'm going to use the same colors I used yesterday. Okay? It's basically saying only A gets added to only B, and we also add the intersection to it. If you added those 3 sections, like in our diagram above, you get the union of the 2 sets. You need to add up these 3 regions to get the union. Do you notice that these 3 regions do not include the outliers, right? Outliers are not included. Then the very last one, this is also true, that the union of the 2 sets, got to pay attention to this one, is adding A, adding all the elements in A, adding all the elements in B, and subtracting the intersection. Do I need to move up with my camera? Sorry. There you go. Let me zoom into that. You gotta subtract. Notice that. Subtract the intersection. Why do I subtract the intersection when I add all of A and all of B and subtract the intersection? This is why. Maybe I'll just do this in your notes here. I don't have this in my notes, but if you consider a scenario, if this is A and this is B, okay, if this is A and this is B, if you add all of A and then you add all of B, you're double counting the middle. If you're doing all of A and all of B, so the intersection, we need to subtract it. We need to take that away so that we're not double counting. So if you're taking all of A, all of B, subtract the intersection, and that is the case. You're loving it, eh? Yeah. Let's use it now. So these formulas are coming with us. Add it to your study sheet. Let's go to 13. Actually, I'm going to skip 13, 14. We're going to go straight to 15. The formulas? Yeah. Back to 12 for a little bit until we get the formulas. Can you write on 12, go to page 15, so you're not wondering like what happened to those pages that we just skipped. And if you're wondering why you're skipping pages, because I'm very ambitious sometimes when I make my booklets. I'm like, I'll do all of this stuff, and then we run out of time. Okay, so I'm going to make up for it as we go. Okay, we good? Let's go to 15. Okay. Is this recording? Yeah, it is. Okay. Venn diagrams and word problems, 2 sets. During the pandemic, a school sent out surveys to 50 homes asking what types of devices were available to students. 30 students were able to access a tablet. 25 students were able to access a computer. And 5 students had access to neither. Draw a Venn diagram and fill out the info provided. Sometimes the problems will use some sort of visual aid or a visual representation to solve this problem. Same thing. Venn diagram is the way you do it. Let's figure out what we have here. We have n of t. They give you a big hint. If they don't give you a hint, you come up with a letter, right? But number of elements that are in T would be 30. The number of elements that are in C would be 25. And what is this talking about here? 5 had access to neither. Outliers. Outliers, that's right. And so basically the notation, you don't have to use the notation. It's just in case if they ever ask you, you need to recognize it, right? In this case, it would be what? T union C, not. Or you could do cut. You could do C-U-T. It doesn't matter. It's the union of the two, not. That is 5. And even if they don't ask you for a Venn diagram, I would say, if you notice this kind of scenario, this is this many and this many and that, and then neither, you're like, wait a minute, this is Venn diagram territory, right? This is Venn diagram territory. So I'm going to do that. A. I'm going to figure out, I'm going to start my Venn diagram like this. This is T. There's 30 students in there. We've got C, 25 students in that set. Do I know my universal? It says up here 50 homes were involved, right? 50 households. So technically, NU is also provided. That's 50. So a lot of information given to you. Sometimes U is the one you're going to find. Okay. 5 goes out here. So me, by default, I put my outliers in this corner right here. And so how would we solve this? I would use pi. And by that I mean the principle of inclusion and exclusion. And the formula that I like the most is this one, which calls for n of t plus n of c minus n of the intersection of those two. So let's fill in what we know. The union is essentially all of my universal, take away any outliers. Don't forget that every time. Union is universal minus outliers. That's when you're left with the union, right? What's left in these sets. N of t, I know, is 30. N of c, I know, is 25. Minus the intersection. So let's clean this up. This would give me 45. This would give me 30 plus 25 is 55 minus x. You can switch over to x if you don't want to write out the notation every single time. In this case, we subtract 55 or you bring over 55. That's up to you. But the goal is to isolate the variable, which is negative. Don't forget that. This would be negative 10. And what do we do when we have a negative x? We want to divide both sides by negative 1. X is equal to 10. And this unlocks everything for us. Once you have the center, because that's what we found here, folks. This is the center, this is the intersection here. So you can take this 10 and say there's 10 elements in here. And I need to make a note, make sure you understand this. There's 10 elements in there, not just one. There's 10 in there. So we're shifting over. If I don't list all of the elements, if all you see is one number in there, for us, that's the number of elements that are found in that intersection. So 10 students have both, okay? 10 students have a tablet and they have a computer. Okay, so how would we find this section right here? If it's 30 for all of it, and 10 are in this section right here, then this will be 30 minus 10. Like this section right here would be 20 students only have a tablet. 30 have a tablet, but 20 only have a tablet. Got it? Then we go over to this side. How many only have a computer? We want just this section here. We go 25, which is all of that, minus 10. That would be 15. Only have a computer. This is what I would call a fully solved Venn diagram, where all three sections are filled in, including your outliers, and you have your universal on the outside. And before you're like, I got it, this is perfect, I'm going to move on, what should all of these add up to? We should get a 50, right? So let's try this. 20 and 10, that's 30, 45, and 5 is 50, so it checks out. So chances are you're on the right track. I will make a note, you can't have negatives. Can't have negatives. All four regions are equal to the universal. Okay, so check for that. So here we go. Now we can start answering. Now that we filled in the Venn diagram, we can actually answer questions that are following. So what is B asking us for? Let's do that here. How many students were able to access both a tablet and a computer? We already know that, right? It's 10. That's showing your work, by the way. You've already done that. So 10 students let's use the proper notation. That'd be, they would, if they ask for notation, that's what they're asking. C. Okay. C. How many students only had a tablet available? What would you say? You'd go grab the 20, right? The 20 represents this region right here. Okay? 20 students. I'm going to use square brackets here. The notation for that would be only T, not C. D, how many students only had a computer? That would be the 15 that are in this section. 15 students. So it's N of C, not T. So order matters, right, in this case. The word only is the one that gives it away, but sometimes it says had a computer but not a tablet. That's the same wording. They're asking for the same thing. How many students had at least a computer or a tablet? It says table. How many had at least a computer or a tablet available? What is it asking us for? At least one. What does that sound like? At least one is not intersection, it's the other one. Intersection is the ones that have both. That we already answered. At least one, it's the union. It's asking for the union. At least one. So there could be a student that had only a tablet, only a computer, or both, right? So we want whatever is in here. So this one is asking for union. Okay? N of T union C. And what would that be? We can actually just figure it out. There's a bunch of ways to figure it out. We could go 50 minus 5 is 45. Or we can say 20, 10, and 15. Or, this is annoying, Mr. Dixon. Don't give me too many options. Just give me one. Okay. Well, if you got the first one, you're good. 45 it is. But you can also get it by just adding every single one of these sections. There's 3, right, in the sets. That's also going to give you the union. And the last one is this one. Watch. 30 plus 25, like all of those, all of C, minus the intersection. So 30 and 25 is 55, minus 10 is 45. So regardless of how you slice it, you get 45. So therefore, 45 students. Okay. Do you want, you know what, I'm going to help you out here with, because when you go through your notes, I think it's easier to, if you go to the Venn diagram, I'm going to say this. Only tablet, only computer, both, and if you're out here, at least one. If it says at least one, it wants the union, okay? Okay, for the rest of today's class, I'm going to ask you to work 16 all the way to 19. Not that you're going to have enough time to do all of that today, but get started. There's no such thing as two of the same. You're going to have to be careful. When you do your Venn diagram, read carefully what kind of wording is being used. And let me tell you this, I honestly don't really care if you're going to use pi the way I've used it, all proper. If you just want to like try with numbers in your Venn diagram and you fill it in, if it works, it works, okay? The province doesn't require you to use the formula if you don't want to. I'm going to say 16 to 20, did I say? Yeah. 16 to 19. There's some word problems with Venn diagrams. There's also something we tried on page 6 where I made our own sets. We write them out, we create them, things like that.